talk, outgoing.
We'll put too much into it. What do they look like? Huh? Female. Oh, they look like me?
Yeah, I have one.
Yeah, I don't have a skirt on today.
I had a few female teachers.
Oh, okay. Okay, so it was a female. What else? Female and what? Old? White. Thank you. We're getting there. How about middle age?
Sure.
Huh?
I was thinking like late 50s, early 60s.
Those are mostly now your subs.
Those are old people, right? Thank you, Lord. Really appreciate that.
Hey, I'm not too far behind you.
I've never given anybody that before midterm, but we got somebody really working on one here now. They are white, they're female, they have 15 years of experience, they are usually married, 44 years old, master's degree, 2 children, and as I always say, white picket fence and a little dog. You can leave the white picket fence and little dog off the list. That is your average teacher. That's who you see in front of the class more often than anybody else. I do know of 4 or 5 elementary schools that have only one male teacher in the building. Guys, if you want a job tomorrow, say you're going to become an elementary teacher, and you will get one. They want male representation in the school. Okay, our book talks about knowing the key characteristics or components of school and grade level education or distribution. Now, that's on pages 34 through 38. When it says that, know the key characteristics or components of school and grade level distribution, what they're saying is, of all of those 4, there are certain things that are more prevalent at a certain age than they are at the other ages. So there are some things that there is a focus, well, obviously the focus overall is education, okay? But in the middle schools, there's something that happens more often in the middle schools than in the high school or the elementary. In the elementary school, there's a certain focus on a certain thing that you would find more in that elementary school than you might find in the high school or middle school. Go through and find out what those focal points are for those different areas.
I'm sure questions will arise.
Can I set this right here? Record.
Suppose I use a 4-letter word or something.
Make it more interesting.
No, I did say a bad thing at one class.
Censor.
I shouldn't do that. I should have said baloney instead of spelling out a BS. Well, somebody was like arguing about something. Okay. How about this number 1? The union of a sperm and an egg in the fallopian tube of a woman, fertilization, forms a what? You all know that, right? From high school.
Yeah.
What can we get you for Christmas?
Christmas is already passed.
Well, I thought maybe we could get you something. All right. Okay. Human gametes have a diploid complement chromosome, a haploid complement, 46 chromosome, a full genomic makeup, all of the above. Haploid. What does that mean, haploid?
23.
Now, in the gamete, is every gene represented, even though they're only half the number as in a diploid? Okay, so every gene is represented. The way the thing goes through mitosis, it ensures that every sperm and every egg has the genes that you need, right? Even though there are only half as many. Does that make sense? All right.
Are you talking about number 2? Yeah.
Yeah. They're a haploid complement, right? So that would be 23, right? Okay, human somatic cells have what?
All of the above.
They have 46. It's diploid. If 2 are right, is that going to be right? The answer?
Yeah.
Are these 2 the same? Okay. So the answer is D. Is there any problem so far?
No.
You see how you are? You overstate everything. You already have a 30.
Just let me freak out, okay?
Okay. Which statement is incorrect?
What is a genotype?
It's like,
All right. Look,
it's a genetic expression.
Always.
Phenotype is like physical.
it's in the chapter, and I said it here several times.
That's like
There are
phenotype,
22
physical trait.
autosomal pairs where the genes are identical, not the alleles. Do you know the difference between an allele and a gene?
What a mess me up.
What do you mean mess you up? A gene does something. It has a purpose, a function. It makes a protein.
A form of it.
An allele is the form of the gene. And the classical example we use are brown eyes, blue eyes, right? Whatever. Purple flower, white flower. Okay. I don't even know what we're talking about. Where are we?
You were going to tell us what number.
All right. So look, you have 46 chromosomes in your somatic cells, right? Are we together? Somatic cells, non-gametes. They're paired, one from the mother, one from the father. Now the sex chromosomes, if you're a female, you have XX. The genes are the same. The alleles may be different because you got one X from your father, one X from your mother, but the genes are the same. In a male, they're a little weird. They have an XY. The genes are different. In fact, there are certain disease states dependent upon that, like hemophilia and other things, where you would, if you have an XX, you have a suppression or this or that, but that Y gets to be a problem when those genes are missing in some types of genetic diseases. So the XY, they're not identical in males. All right, so let's see what we're saying here. Which statement is incorrect? Most phenotypic traits can have more than one genotype. Huh? Look, if your genotype has an allele for brown from your mother and father, what color are your eyes going to be? If you have a brown from your father and a blue from your mother, what color are your eyes going to be?
Brown.
So here's one sibling that has a brown and has brown eyes. Here's another sibling that has a little brown and has brown eyes. Phenotypically the same, but genotypically are they the same? They have different alleles, right?
Okay.
So, most phenotypic traits can have more than one genotype. Is that true? Yes. You can have different alleles, right? And different genotypes. But if you have a dominant allele, you can wind up with the same phenotype. Why do you all look like glazed over when I talk about things like this?
I just read the second one. It was like
Okay, the genes of two sex chromosomes in males are matched at corresponding loci on the two chromosomes. No. If you look at the loci, the Y is a much smaller chromosome, and it has a lot of genes missing that this X does have, right? So you can't match them gene for gene. Are you okay? So that's no, by the way, that could be the answer. Where are we?
Which one?
I don't know.
4 is B.
The 22 autosomal, now these are the non-sex homologous chromosomes, one from mother, one from, and both males and females have genes of the same character. Yes. The only ones that may be a little different are the male XY. Phenotypes resulting from an expression of homozygous recessive, homozygous dominant, and heterozygous codominant alleles will each have only one genotype. Right. If you're homozygous recessive, any homozygous, if you have an allele, and they're both the same, one from the mother, one to the father, right? That's what homozygous means.
I think when I read that initially, like I clumped all of those together, like they had, I don't know, but I figured it out.
Well, if you have a brown, you're not going to have blue eyes.
Yeah. I don't know. I
If you have an AB,
square or whatever.
An AB, wait a minute, A from mother, B from the father. What's your blood type going to be? Can it be anything else? All right. And if you have a little b for eyes, or no O for blood, you're going to have blue eyes or So if you're homozygous recessive or homozygous dominant, there's only going to be one phenotype. And if it's codominant and it's heterozygous, if they're codominant, then you're going to have, like any classical example of that is AB blood type. A from the mother, B from the father, your blood type will be AB. I think that's true. What's the only one that's false? Can you have more than one statement incorrect if there's only one answer? No. Okay. Which combination of the following statements is correct? Okay, we need a combination here. Can I go through these? A male who is genotype BB mates with a female genotype will have children that are all heterozygous for eye color. Because you can have a BB, little b, right? Big B, big B. They'd be homozygous. By the way, is the trouble the words heterozygous, homozygous, allele? Huh?
I understand that.
Okay.
No, it's just when they use a whole bunch of those kind of words that you're still kind of unfamiliar with and you're just testing them out, and then they put them all together with other words that you're just learning. That's what it is.
Well, one is incorrect. Do you agree with me?
Yes.
All right. A male who is genotype little b, mates with a female big B, little b, will have brown-eyed children and blue-eyed children in a ratio of 1 to 1.
It's true.
Well, you can figure that out, right? You can make up a Punnett square. Or there's a quick way, like an algebraic expression that you should do it. You see it will come out 1 to 1? Now, the blues will be homozygous, but the browns could be hetero or homo, and it comes out 1 to 1 because... All right. Shall we work it out with a Punnett square?
No,
I don't think I got it.
You did that? Okay. 3. So 2 correct or not?
2
Two is.
1 is not. 3. A male who is genotype BB and mates with the female big B, little b, will have brown-eyed children and blue-eyed children, ratio 2 to 1. No. That big BB is my mother. She had, and we all have brown eyes, even though my father had blue eyes. So once you have a big B, a dominant homozygous, all the children are going to be that color, right? So they're going to be all brown-eyed, as a matter of fact. 3 is incorrect. So far, we only got 2. 4. When a male genotype big B mates with a female, their children can only receive an allele for blue from the mother. Say no. Because you're going to make gametes, right, that are going to be B or little b, so that's false. You all see that? If you did a Punnett, B. Okay, we got to go through this. You people are way behind. A male of genotype BB who mates with a female genotype will all have brown-eyed children. Well, either 3 or 5 is correct, right?
Yes.
So I get 2, 5. What do you get? Did you have trouble with that one? No? All right, how about this one?
This one I did because I didn't realize where the O was coming from.
Oh.
Like, I read the question, but I just didn't get where the O was coming from.
Well, let's see. The alleles for blood type ABO are on chromosome 9. All right, you remember there are 22 chromosomes. They're numbered 1 to 9, and they're paired. So the one from the mother's called 1, and the one from the father's called 1. The 2 from the mother's called 2. All right, so there are only 23 numbers, but there are really 26 different chromosomes. Okay, so they're on chromosome 9. Now remember, you got a chromosome 9 from your father and 1 from your mother, right? The allele for RH plus minus are on chromosome 1, right? A male is heterozygous for blood type A. As soon as you hear that, what's the genotype of the male?
Big A, little A.
Not little a, we usually call it O, but see, you got the idea.
Oh, okay, so it's O.
It's AO, right?
If it's
We have
a blood
ABO.
type- Well, because if it was AB, then it would have to be co-dominant, right? Is that why they didn't make it AB?
The blood type means the phenotypic type of blood. It's A. If it's heterozygous, this person does not have an AA.
Oh, it's so cold!
They have to have an AO. If they had an AA, they'd be homozygous.
No heat. Furnace is fucking broken.
Why couldn't they have a B? Is it because it's codominant?
Well, if they had an AB, they wouldn't be an A type. They'd be an AB type.
Okay, so it had to be.
I'm always so
Well, you see, that's the
confused
point.
in class.
If you knew these words well enough, heterozygous, blood type
I know what
A
that means.
must be an AOG, a genotype. See, that should ring your bell immediately. And I can understand if it doesn't.